Hi, a very good morning, my dear students. Let's continue the chapter units and measurements. In this units and measurements, the first topic here units and dimensions we have done. We have done with units and dimensions. When it comes to measurements, experimental errors, error analysis and measurements. So here units and dimensions we have done. When it comes to measurements, we will be discussing about errors and error analysis and measurements. Alright. In this, how the concept of dimensions is very important for the board exams or entrance exams. Here, the error analysis is having a lot of importance for your board exam as well as entrance exams. Alright. Now, when we start the measurements, and we will be starting with measurements and we will be moving to the errors concept. Right. Now, we will be starting with multipliers and submultiples. Multipliers and submultiples. What are multipliers and submultiples? We'll be discussing now. 10 raised to 3, 10 raised to 6, 10 raised to 9, 10 raised to 12. In the same way, I am writing here 10 raised to minus 3, 10 raised to minus 6, 10 raised to minus 9, 10 raised to minus 12. You know, these are called multipliers and these are called submultiples. And this 10 raised to 3, I can say it is kilo. For example, 10 raised to 3 grams, that means kilogram. 10 raised to 3 meters, that is kilometer, right? So let me write somewhere else. So if I write 10 raised to 3 into meter, so that's called a kilometer. Alright. So when I write 10 raised to 3 into kg, so that is called 1000 kg. So 10 raised to 3 grams if I write, so that is 1000 gram, which is equal to 1 kilogram. In that way, your 10 raised to 3 will be useful. In the same way, 10 raised to 6, 9, 10 raised to 12 also. So kilo, and this is what called a mega, right? So this is giga and this is tera. The value of 10 raised to 3 is kilo, 10 raised to 6 is mega, and this is giga and this is tera. Let's concentrate on submultipliers or submultiples. 10 raised to minus 3 is milli. Right? So if I write 10 raised to minus 3 grams, that's called 1 milligram. 10 raised to minus 3 meter, if I write, that is millimeter. Okay. 10 raised to minus 6, so that is called a micro. What is that? Micro, denoted with the symbol mu. Sorry, see here, denoted with the symbol mu. So the pronunciation of this is mu, mu, that's it. It's a Greek one. 10 raised to minus 9, it's called nano. What is that? Nano, denoted with the letter small n. So if I write 1 nanometer, that will be equal to 10 raised to minus 9 meter. No confusions at all. This is how the nano symbol will be used. So what is 1 micrometer? That is 10 raised to minus 6 meters. Alright. 10 raised to minus 2. So this is denoted with a symbol called pico. denoted with symbol small p. These are multipliers and submultiples. Alright, my dear students. Now, the actual concept of measurements will be moving in. So, in the measurements, actual concept of measurements we are moving. In case of measurements, carefully see, we have three fundamental physical quantities: a mass, length and time. Mass, length and time. Look at here. These are the fundamental physical quantities, and let's measure how the length will be measured, how time will be measured, how mass will be measured. We'll be discussing one by one. So first thing, how the length will be measured. So our distances are measured. So around us, there are some distances which may be small or which may large. Large distances. Distance between the Earth and the planet. Distance between the Sun and the planet. Distance between the Earth and the Moon. Distance between Earth and the stars. Distance between the Moon and the stars. Those are the large distances. Okay. So always remember large distances, especially planetary distances, are measured with a method called a parallax method. What is it called? Parallax method. What is the parallax method? I'll tell you here. Listen to me carefully. It's so simple. Imagine this is a planet or moon or a star, anything. So this is the planet, will have two ends. Those are called diametric ends. So that's called what? Diametric ends. So the diameter here is D. So we are looking the planet from here, right? Through the telescope, astronomical telescope especially. When we are looking or observing from the Earth, so you can see the two ends here. So this is one end and this is the another end. So this is called D. Capital D is distance between us and the planet, right? So this is also D. Distance between the Earth and the planet. So this is the Earth. And you can say it is a planet. Alright. So you can see there is an angle made by us while looking at this, that is called theta. And we know the concept called plane angle. Already I have told you the plane angle is denoted with the symbol theta, which is equal to plane angle, length of the arc by radius of the circle. So this is act as a radius and this will act as a length of the arc. Understand? Clear? So theta will be equal to a length of the arc by a radius. So from here theta value we have got. The important thing is our aim is to find a distance between Earth and the planet, capital D. So from here capital D is equal to small d by theta. Remember. Sometimes they may ask you the question, what is the size of the planet? Size of the unknown planet. The size of the unknown planet is D. Diameter, if you know, you can find out. So the diameter is equal to capital D into theta. This is size of the planet. Alright. Alright. Now we'll write small d is diameter of the planet. Capital D is distance between Earth and the planet. Alright. This is called the parallax method. Remember. You may get a doubt. This is how this will act as a length of an arc. I'll show you here. Generally, this is called, if it is the center of the circular path, this is called length of an arc. When you take a large circle, when you take a huge circle, this length of an arc will be almost a straight line. How? Look at here. If this is a smaller circle, all right, this is a smaller circle. If you take a huge circle, what happens? See, if you take a huge circle, a small part you take, that is almost a straight line. Understand? So this is how we can discuss the parallax method, right? The probability of asking a question from the parallax method in your NEET, JEE and CET exam is 0. In none of these years, the question asked from parallax method. No question, right? Just try to understand. Large distances are measured, especially the astronomical distances are measured by using parallax method, and the smaller distances, for example, length of this pen can be measured with a small scale which is called meter scale. Okay? And smaller than this, for example, diameter of the nib, that you cannot measure with your meter scale, right? So such kind of smaller distances can be measured by using the instruments called vernier calipers. What is that? Vernier calipers, screw gauge, spirometer. So these kind of devices are useful in measuring the smaller distances. How much small? As small as 10 raised to minus 5 meter. 10 raised to minus 5 meter. It's so small. Smaller than millimeter. 1 millimeter is just here. We have written somewhere here. 1 millimeter is 10 raised to minus 3 meter. So lesser than the millimeter value you can find by using these vernier calipers, screw gauge and spirometer. My dear students, I hope you all are getting the point. Alright? Clear? Now, some more units to measure distances. Some more units to measure the distances. Listen to me carefully. 1 Fermi is equal to 10 raised to minus 15 meter. You know how small it is. Some more units to measure the distances. Right? Now, 1 angstrom. Look at here. Fermi. It is denoted with the symbol a small fm. 1 angstrom is equal to 10 raised to minus 10 meter. So this is denoted with the symbol a raised to 0. A raised to 0. Sometimes the 0 will be here also. No confusions at all. That's called angstrom. Most of the numericals will be having angstrom and nanometer. 1 angstrom is 10 raised to minus 10 meter and nanometer will be 10 raised to minus 9 meter. Alright. Now, 1, look at here, astronomical unit. 1 astronomical unit. You know, 1 astronomical unit will be equal to 1.496 into 10 raised to 11, right, meter. See how big it is. Some more distances, some more symbols or units to measure smaller distances are 1 Fermi, 1 angstrom unit. Some more units are the distances to measure the huge distances, like you can say planetary distances. We'll use this. Astronomical unit, see how big it is. 1.496 into 10 raised to 11 meter. You know what exactly meant by the astronomical unit? It is the average distance between, see here, it is the average distance between Sun and Earth. It is the average distance between what? Sun and the Earth. Alright. Now, the next one is 1 light year, denoted with the symbol L suffix Y. So before that, 1 astronomical unit, so it can be written in this way. 1 AU is equal to, so this much. No confusions. 1 astronomical unit. So here, 1 light year. So 1 light year is equal to 9.46 into 10 raised to 15 meter. See here, what is light year here? Most of the students think that light year is the unit of time because it is year. Light year is the unit of time. Most of the students think that. And you believe it or not, starting from the government job exam, entrance exam for a government job, starting from based on your SSLC. For example, to apply a clerk job in a post office, the basic requirement is your SLC. Fine, or 10th standard. In bank exams, a minimum you need to finish the graduation. In any other exam, like railways, right? Any other department, government department you take, the entrance exams you need to write. In those entrance exams also, under the category of basic science, this is the very important commonly asked question. Commonly asked question. You know what is the question? Light year is the unit of time or distance? Tell me. Light year is the unit of time or distance? Distance. Because 1 light year is equal to 9.46 into 10 raised to 15 meter. Alright. Clear? Now, what is light year? We will be discussing just now. Before that, 1 parsec is equal to, listen, 1 parsec is equal to 3.26 light years. That means 3.26 into 9.46 into 10 raised to 15. That's called 1 parsec. Okay. So these are the units. Some more units to measure the small distances and large distances. And these are basic things about a distance. This is a basic thing about measuring the length of the distance. Now we'll be discussing about measuring mass and time. Alright? My dear students. So before moving to the measurement of a mass, let me write what is a light year. A light year. It is the distance traveled by light in free space. I can say it's vacuum. The distance traveled by the light in vacuum in a year. In an year. That means in 365 days, the distance traveled by the light in vacuum is called a light year. And the value of the light year also I had written already. It's a 9.46 into 10 raised to 15 a meter. Alright, it is 1 light year. So finally what I can say, light year is the unit of what? Distance. Okay. It's not the unit of time. It is the distance. Measurement of mass. We know SI unit of mass is kilogram. So there is some standard unit of mass is also present. The standard unit is, carefully say, AMU. What is that? AMU. That's called atomic mass unit or unified atomic mass unit. No confusions. That may be unified atomic mass unit or atomic mass unit. Is it clear? Alright. Now, what is this unified atomic mass unit, I'm going to tell you now, listen to me carefully. So it is mass which is 1/12, 1/12 of mass of a carbon, which is represented as C12, right? Carbon. 1/12 of mass of a carbon isotope. Any carbon isotope you take, 1/12 of mass of the carbon isotope is called AMU, which is atomic mass unit, right? Now, one atomic mass unit is how much? So this is also a very important numerical value. It is 1.66 into 10 raised to minus 27 kilogram. How small it is, you can see. So that is also a standard unit of mass. And in smaller units of mass, 1 milligram, gram, right? So I can say milligram, gram are the smaller unit of masses. Smaller units of masses. Clear? Now, there's a measurement of time. Measurement of time. Generally, the standard measurement is, the standard measurements I'm writing here, the standard measurement is from the vibrations produced in cesium atom. Standard unit of time is taken from the vibrations produced in the cesium atom. So this standard measurement of time is taken from the cesium clocks. Even our IST, means Indian Standard Time, is also taken from the cesium clock only, which is present in a National Physics Lab, which is NPL Delhi. Our Indian Standard Time is managed and maintained in the cesium clock, based on the cesium clock which is kept at National Physics Laboratory, New Delhi. Right? Now, a measurement of time. 1 second, minutes, hours, days, months, years, those are the measurement of time. So this is about the measurement. Now, we need to focus on few important things before moving about the concept of error. What is the error? Least count. See, accuracy and precision. One by one we will discuss. All four are important terms. Error, least count, accuracy and precision. Let's see what is the least count. So here, let me write here. Least count. You know what is meant by the least count? It is the smallest value that can be measured. The smallest value that can be measured by any instrument. So that is called its least count. For example, let's take your small meter scale, just 15 centimeter or 30 centimeters. Small meter scale will be there, right? How you will be starting its count, its measurement. 0, 0.1, 0.2, 0.3, 1. Understand what is that? 0 point is what? 0.1 centimeter, 0.2 centimeter, 0.3, 0.5, 0.9 and 1 centimeters. Alright? Clear? So each division is representing 0.1 centimeters in your meter scale, isn't it? So that is called the smallest value that can be measured by the meter scale is 0.1 centimeters. So in case of a meter scale, its least count I can say it is 0.1 centimeters. For example, take your wristwatch, which will have some dial, right? So not the digital clock in this way, so dial. So in case of dial, so there will be a minute's hand, hours hand and seconds hand. So they will be rotating about the fixed axis. So the smallest measurement that can be measured by the wristwatch is how much? 1 second, yes or no? So 1 second. So in case of the wristwatch, it will be 1 second. Imagine you have taken a thermometer, alright? Thermometer which is having degree Celsius. So imagine the thermometer what you consider having the values in degree Celsius. So the smallest value that can be measured, the smallest reading that can be taken is 1 degree Celsius. I am just imagining it, assuming it. So likewise, the smallest value that can be measured by any instrument is called its least count. Alright? Clear? Now, for example, I have an instrument which is measured the length of an object in this way. The length of an object is measured by 2.46 centimeters. That may be the diameter, right? That may be the radius, anything. So length is measured with an instrument. I got a result 2.46 centimeters. What is the minimum value that can be measured like this? What is the smallest value that can be measured? Definitely it will be 0.01 centimeters. Look at here. After the decimal, how many digits are there? 1, 2. Only 1, 2. So this will be the least count of this instrument. With what instrument this measurement has taken? I hope you got the point. For example, I have a meter scale. Its exact measurement is 13.5 centimeters. This pen exact measurement when I use a meter scale to measure this, I have got this value. What is the minimum value that can be measured by the same instrument? That meter scale. What is the minimum value that can be measured? And what is the smallest value that can be measured? 0.1, because after the decimal it can only measure 1 digit. That's called its least count. With this much detailed analysis, know where you get. Whatever may be the topic you take. That's called the least count. Alright? Clear? So this is about the least count. And before going to the further, let's concentrate on this error, the small things, error. It's so simple. The error may arise. Error means what? It's simple. In simple words, you can say it's a mistake or uncertainty. What is that? Error may be a mistake or uncertainty. In which case these errors or uncertainties develop, I'll tell you. Listen. I have a meter scale. Our aim is to measure the length of it. I have a meter scale. Our aim is to measure the length of it. Carefully go through it. The actual length of it, I'm writing here, the actual length of it is, I can say it is 14.6 centimeters. Alright, actual length of this is called 14.6 centimeters. That is, while making the pen, during the manufacturing of this pen, they have given me. Understand? So this is the actual length, and this is the value is also called as a measured value. What is it? A measured value or a true So this is the value is called true value. Measured value is different. Okay. So the actual length I have got when I am purchasing the pen or when I am manufacturing the pen, it's got 114.6 centimeters, and that's called the true value. Alright. Now I have measured it by using the meter scale. By mistake, I have not kept exact 0 point here. I have kept somewhere here or somewhere the other side. I hope you're getting the point. I have not kept exactly the 0 point at the starting of this pen. I have kept left side or right side of the starting point. That means definitely you'll get a wrong answer. Yes or no? Right? For sure you'll not get the actual length. Because while measuring, it's a mistake of mine. Mistake of the person who is doing the experiment. Okay, so the errors may be possible due to the personal error. That's called a personal error. Alright? And the error may be possible due to the instrumental error. What is that? Instrumental error. So that instrumental error is also called as calibration error. Calibration error means while making the meter scale also, there is a possibility of getting a mistake. Understand? There is a possibility of getting a mistake while making the device itself. If you see the distance between any two divisions, any two immediate divisions I am talking about, the distance between any two successive divisions must be same. During the manufacture, during the calibration or making the instrument, suppose if there is a problem with maintaining equal distance between two successive divisions, what happens? There will be a problem in the final value. Yes or no? Definitely your value will not be equal to actual length. Is it clear? Clear. So the errors may be possible due to the personal error or instrumental error. Listen, when the error is due to a personal error, always it will not be there. It will not repeat even. Right? Sometimes I can put exactly correct. Sometimes I can keep left side. Sometimes I can keep right side. Personal errors comes under the category of random errors. What is that? Random errors. Whereas instrumental error, they comes under the category of systematic error. What is that? Systematic error. That means continuously the error will be there. Continuously the error will repeat. In any measurement you take, the error will repeat because there is a problem with the instrument. My dear students, hope you got the full clarity related to the error. What is the error? Okay, now see. Actually, I have got this one. Now, either maybe personal error or due to instrumental error, I have observed the value. Observed or measured. Observed or a measured value. I have got it as a 14 point, so I can say 14.7 centimeters. So there is a difference, right? So error is the difference between measured value and true value. My dear students, listen. Error is the difference between measured value and true value. So this is the error. What is the measured value here? 14.7 centimeters minus true value is how much? 14.6 centimeters. So this is 0.1 centimeter is the error. This error may be positive, this error may be negative because this value may be less or more than this. So this error may be positive or negative. May be positive or negative. Is it clear? Sure? Now, the topic comes accuracy. What is that? The topic is accuracy. Accuracy and precision are two important things while doing the experimentation. While doing the experimentation, accuracy and precision are two important things. Yes, that we'll be discussing now. Well, my dear students, so the thing we need to discuss about accuracy and precision. So simple. Let me tell you what is accuracy first. Accuracy it is a measure of how close the measured value is to the true value. Got the point? How close the measured value is to the true value. See, the true value, I have told you, our experimentation is so easy. The length of this, our experimentation is so easy. We have kept the experiment, what we are doing is so simple. Just by using a meter scale to measure the length of this. Understand? So I have measured the actual value I told you during the manufacture of this pen. The length of it, they have got 14.6 centimeter. Now, accuracy is the measure of how close the measured value to the true value. This is the true value. Now, I've measured first measurement or a first person. I have given a scale and the same pen. Same scale and same pen. First person measured it 14.2 centimeters. The second measurement or a second person measured it 14.8 centimeters. And the third person measured it as 14.7 centimeters. Alright? 14.7 centimeters. Because there may be chances of personal error that may be different for each and every person. Or for the same person also, the personal error may be varies for each and every measurement. So that is why we have got random values. It doesn't mean that you will never get 14.6 centimeters. You may get 14.6 centimeters. And there is no concept of accuracy or precision in that case. In that case, your measured value is equal to true value. Problem solved. Right? So the accuracy means how close the measured value is to the true value. What is the true value? 14.6, and find out which is closest to your true value. 14.2, 14.8 and 14.7. Yes, this 14.7 is accurate out of the given measurements. Understand? So this is accurate value. The accuracy of this is more. Simple. Now the precision. Precision is up to what limit of resolution the measurement up to what resolution the measurement will be given by an instrument. All right. The precision will depend on the instrument. Each and every instrument will have its least count, yes or no? Each instrument will have least count. Remember, will have the least count. So why I am talking about the least count here is the precision is having the connection with the least count of the instruments, because here instrument is same. The person or the measurements are different. But here instruments will be different. For each and every instrument, the precision will be different, least count will be different. Okay. Look at here. The length of an object. Length of an object or diameter or radius, anything. So I have got it as 2.224 centimeter. Okay. So this is the first instrument. Okay. I have taken another instrument, right? Measured the same length. So I have got it as 2.2 centimeters. So this is the second instrument. See the interesting thing here. After the decimal, this is the instrument is able to measure 2 digits. And this is the instrument is able to measure only 1 digit after the decimal. Okay. Clear? Now here another instrument I have taken. It is measured 2.356 centimeters. Look at the interesting thing. Third instrument is measured after the decimal 3 digits. Come back to the definition of precision. What is precision? Precision is up to what limit of resolution the measurement will be given by an instrument. After the decimal point, how many digits can the instrument measure? So more digits can the instrument measure after the decimal point. So that instrument is more precise. That measurement taken by that instrument is more precise. Here there is no concept of accuracy here. Only we need to check after the decimal how many digits that particular instrument measure. That's it. Alright? Clear? See, no concept of accuracy here in case of precision. No. Right? The next classes. More concepts about error and error analysis will be doing it. More concepts related to the error and error analysis we'll do in the next class. All the very best and get ready for your online assignment. Thank you so much.